Last weekend, I saw this movie, Astra, starring Brad Pitt. This movie is pretty awesome. It has space elevator, it has Mars, moon, fight sequence in zero gravity or microgravity. However, what it doesn't have is physics. Okay, in this video, we'll analyze the physics in the climax of this movie. But before that, let me give you the synopsis of it. Brad Pitt, who goes by the name of Roy McBride, he's an astronaut, a fearless, cool-headed astronaut. He has been given a task to go from Earth to Neptune across the solar system and disable, disarm, destroy a possible antimatter pulse generator. That antimatter pulse has been generating pulse towards Earth and causing power surge, which is not good, I guess. Let's just go to fan sequence and see how it transpires. So in the final scene, Brad Pitt takes his spaceship Cepheus, goes to Neptune, and then from there takes a small pod, goes to Lima, and then enters Lima, places a nuclear bomb, had a bit of scuffle with his father, and then tries to go back to Cepheus. Okay, let's first calculate the speed of Lima, Cepheus, and Brad Pitt himself. They're not at rest, of course. Nothing in space is at rest. They must be orbiting Neptune at some speed. What is that speed? Okay, to calculate the speed of Lima, we need to use this equation. We know what is gravitational constant and the mass of Neptune. All we need to know is the distance of Lima from the center of Neptune. Let's just take a well-rounded random number, say 100,000 kilometers. Okay, let's plug in all the values to this formula, and the speed, the orbital speed, comes out to be 8,124 meters per second. That is also the speed of Brad Pitt. But that speed means nothing because Cepheus is also moving around Neptune at the same speed. So the relative speed of Brad Pitt, Roy McBride, is 0. He needs to have extra speed. So where would that extra speed come from? Cool-headed Roy McBride looks around and finds an inverted ceiling fan. He climbs to this antenna, transceiver, or whatever you call it, and lunges towards Cepheus. Let's take a number. Say that Roy needs to have a speed of 10 meters per second to reach Cepheus. But what should be the speed of rotation of this antenna to provide enough push so that Roy attains 10 meters per second? Let's calculate that. Since here we are talking about rotations, so we'll not be talking about normal velocity, but we'll be talking about angular velocity. So angular velocity represented by W would be equals to velocity that Roy would want to achieve divided by the radius of this antenna. Let's again assume some numbers. Let's just say that the radius of this antenna is 10 meters. That gives the angular velocity to be 1 radian per second. Let's see how much time would the fan need to complete one revolution to attain 1 radian per second. The time taken would be 2 pi divided by the angular velocity. Plug in the values, we find it to be 6.28 seconds. So to complete one revolution, that antenna need to take just 6.28 seconds. But does it do that? Let's see in this movie. Yeah, it didn't take that. It took a lot longer. Now, you see this? Roy McBride also lunges towards Cepheus. So maybe that lunge is going to provide him that extra push. So how much energy does his muscle needs to generate so that Roy gets the speed of 10 meters per second? Let's calculate that. As per kinetic energy equation, the energy required would be half into mass into velocity squared. Let's just assume that Brad Pitt is 80 kilograms, a well healthy guy, and the velocity is 10, right? So plugging these values, we find that the energy required will be 4,000 joules. For reference, a high jumper in Olympics generates roughly 200 to 300 joules. Roy's muscles should be strong enough to generate at least 10 times that value. Not just that, finally we'll also have to see the timing of the jump. If Roy errs on timing of his jump, he may land up in some other place. If you have seen other space movies, you'll see that all these astronauts scribble around to get correct mathematics to either turn their ship towards Earth so that their inclination or the timing to enter the atmosphere is perfect. Over here we see that Roy does not do any calculation, he just times his jump. For calculation, let's assume that he mistimes his jump, and he mistimes his jump by a ridiculously small amount, like just 0.1 second. So the change in radiance or change in the distance where he would land up with this small error would be given by this formula, and that becomes to 0.1 radian. Let's assume that Lima and Cepheus are at some distance, of course. Let's just take they are just 10 kilometers apart. Plugging 10 kilometers into this value, it gives that even a slight mistiming as small as 0.1 second will make Roy end up a kilometer away from his destination. Of course, we see that he does some course correction, but he does course correction right at the end to cover, which would be rather difficult with course correction to cover 1 kilometer. Not just that, how about the speed? So we have taken a very small amount, like just 10 meters per second. If we take 10 meters per second, Roy would take about 100 minutes to get from Lima to Cepheus. But in this movie, we saw that he times nuclear weapon for 3 hours. Now with that speed, would he be able to make to Cepheus within time? You let me know. And what about this scene? We see a nuclear explosion happening that gives Roy and his spaceship somewhat of a push, and that push helps Roy's ship attain a greater speed. There's a big problem with this scene. Here, the nuclear explosion is shown to be happening somewhat like it would happen on Earth, but there's no atmosphere in space, so all these dramatic explosion will not be happening in this space. And secondly, nuclear explosion giving push, it has to be ridiculously close to the spaceship, and the direction has to be opposite, not towards the spaceship. If the source would have been very close to Cepheus, Roy will be evaporated just like that. Let's say that he is well shielded, his spaceship is well shielded. He would be severely injured if he is too close to that nuclear weapon. So with all these things into mind, I think Newton and Einstein would have been very disappointed after seeing this movie. Okay, let me know what your views are in the comment section, and I'll see you next time around. Bye bye.